In this video, we'll be finishing up our Punnett square packet. This is on page 8 of the packet, the very last page, and we'll be talking about test cross. So a test cross is performed to determine the genotype of an individual whose dominant phenotype we know. So we know that the individual is expressing the dominant trait, but we don't know if their genotype is homozygous dominant or heterozygous. So we can perform a test cross. The test cross could be performed by actually crossing or mating individuals, like if we're talking about plants or chickens or something like that, but we certainly wouldn't do this with humans. In that case, we would simply do Punnett squares on paper, which is what we'll be doing with our practice. So a test cross is performed here to figure out the genotype of the individual when we know their dominant phenotype. So in this case, we have to perform 2 Punnett squares. And in both cases, we're going to cross the dominant, homozygous dominant, and the heterozygous dominant individual with homozygous recessive. The reason we use homozygous recessive is it gives us the best chance of getting the recessive in the offspring and therefore determining most likely the genotype of the parent. So I'm going to do the first one with you, and then you should pause the video and then see if you can do the second one on your own, and then you can check your answer. I'll publish the answer key as well. So taking a look at our questions here, what's the purpose of a test cross? The purpose is going to be to determine the unknown genotype of an individual with a dominant phenotype. And in a test cross, we don't know the genotype of the first parent because they're either heterozygous or homozygous dominant, but we do always know the second parent, which is going to be homozygous recessive. So here's an example. So we have a gardener that has a tall plant. He does not know the genotype, which means that plant could either be homozygous dominant or heterozygous, but maybe it's very important that he determines the genotype because he wants to know that he is surely going to get dominant offspring. So he would definitely want to know if the parent plant is going to pass down the dominant trait or the recessive trait. So what can the gardener do to determine that genotype of that dominant plant where we know its phenotype? So the answer to part A is perform a test cross. And we'll be doing this on paper, but since he's working with plants, he could certainly do this cross in reality. So here's how we set this up. We're simply going to show our 2 possible Punnett squares. So we know that he's working with pea plants, and we know the alleles that we would use, or letters we would use, to represent our pea plants. So we know capital T is tall, we know lowercase t is short. Be sure to use the capital and lowercase of the same letter. So his first plant, the dominant plant, is tall, so it could be either homozygous dominant or heterozygous. Our second plant, remember, we're always going to use the homozygous recessive. And we can simply do our basic Punnett square. Now, what is the purpose of this? So once we see the offspring, we can then determine if the parent is heterozygous or homozygous. If all of the offspring show the dominant trait, so in this case all of the offspring are showing the dominant trait, then that parent is most likely going to be homozygous dominant, our first parent. If we have any recessive traits being expressed, then we can tell for sure that our first parent is heterozygous instead. If we do this cross enough times, we can be confident, most likely, if it's heterozygous or homozygous for that first parent. There's another problem here. Number 4. At this time, I'm going to pause the video, and you should too. Try and do number 4 on your own, and then come back and check your answer. Okay, so I performed numbers 4 and 5, so you should come back and check your answers at this point. If you haven't already paused, please do so and try these on your own. You'll notice that number 4 is a little bit more involved because it asked you a question now with the offspring results that they found. So for number 4, I have my key here, so the black coat is dominant and the white coat is recessive. So I'm simply going to perform my 2 Punnett squares for my test cross. So our test cross Punnett squares are always going to look the same. So we have our homozygous dominant parent crossed with our homozygous recessive, and then the other opportunity for the dominant parent would be heterozygous, and that's also crossed with homozygous recessive. So notice in the problem you're told that 5 of the offspring are black and 5 are white, so here's my offspring that were actually found. What's the genotype of the dominant parent? So if we have any recessive show up, then it tells us that our parent must be heterozygous, because there's no opportunity to get a recessive showing if the parent is homozygous dominant. So the fact that we have the recessive showing here tells us that our parent must be heterozygous. Okay, and here's our Punnett square that shows that. We technically do not have to perform both, but I wanted you to see it. So for part B there, if the male parent is heterozygous, what's the probability the offspring will be black? Well, here is our Punnett square. So we have our heterozygous parent that they told us, and then homozygous recessive, of course. And what is the probability that the offspring will show the dominant? We're simply going to look at our dominant here, which is 50%. Number 5 is another example. We've had a couple of questions here to answer. Notice my key, I chose an A. Straight rings are dominant over curly rings. I don't think a letter S is a great letter to choose. I don't think C is a great letter to choose. I don't think W is a great letter to choose. So I went with A, so I could easily distinguish the dominant and recessive. So how do you figure out if our straight ring fly is heterozygous or homozygous? Well, we simply perform a test cross. So that's your answer there. And then, of course, our Punnett squares look like they have before, with our homozygous dominant opportunity and our heterozygous opportunity for parent 1, homozygous recessive for parent 2. And there's our 2 Punnett squares. So test cross are pretty straightforward. It's just a matter of determining the genotype of our unknown phenotype, which is dominant.